Hi there, welcome to this video. Thanks for clicking on and watching. Hopefully you've done so because you're studying maths A level and you've either already met the equation of a circle or you want to get ahead and have a little head start on all things circles. So that is exactly what we're going to do in this video. Run through what the equation of the circle is, the type of questions you get, and go through some exam questions as well. So let's get into the video. Here are all the particular topics that are included in this video. If you wanted to go to a certain one, all you need to do is use the drop down arrow at the bottom of the video next to the word more, and you'll see the description, and there are timestamps in the description, so you can just click on them to go to a particular topic that you want to view. Having a look at perpendicular bisectors and midpoints and words that are associated and used when we're looking at circle problems. A chord is a line that goes from one side of the circumference to the other, and the perpendicular bisector of a chord is going to cut that chord in half at right angles, and any perpendicular of a chord is going to be either the radius, or if we extend it, the diameter. The special name of the chord that goes from one side to the other and goes through the center, of course, is the diameter, and radius being half of that. The other thing that we use with circles is tangents. So tangents are lines that just touch the circle. So here we've got an example, not to do with circles, but just to do with perpendicular bisectors. We're trying to find the equation of this more solid black line here that goes between 2, 5 and 6, 7, and it is the perpendicular bisector of the line joining A to B. So that means it cuts A to B in half at right angles. So in order to find the equation of a line, we need the gradient and we need a point. So we need to find this midpoint. So thinking about going horizontally, the coordinates that are the horizontal coordinates are the 2 and the 6. If you just think on a number line, what is halfway between them, that's going to be 4. And then looking vertically, looking at the 5 and the 7, what's halfway between them vertically, it will be 6. Now, if it wasn't as easy to spot, that's just what's halfway between, the what we can use to find the midpoint is the average of the x coordinates and then the average of the y coordinates. So x1 plus x2 in this case would be 2 plus 6, and then find the average. The y's would be 5 plus 7, find the average, and that would just give us the coordinate of the midpoint. So if we couldn't just spot what's halfway between 2 and 6, just add either end. 2 plus 6 is 8, and half of that gives us the 4. 5 plus 7 is 12, and half of that is 6. Now, in order to find the equation of the line, we've now got our point. We now need to find the gradient of the line. So when we're going to have lines that are perpendicular, if you think of the line y is equal to 2x, the gradient is 2. And if we think about the gradient, for every 1 along, it's 2 up. Now, for every how much that line is steep, in order to have the perpendicular line, then to get the right angle there going through the origin, the rise and the run just need to change round. So this is going to be 2 in the run and 1 in the rise. So the 2x line is going uphill, so the gradient is positive. The perpendicular line is going downhill, and it's going to be y equals minus half x. So perpendicular lines have the negative reciprocal gradient. So if we just find what's the gradient between 2, 5 and 6, 7, we can see horizontally the run 2 to 6 is 4. Vertically, to go between 5 and 7 is 2. So the m of the line AB is going to be 2 over 4, which is a half. So the m of the line we're after, the perpendicular bisector, is going to be minus 2. Now we just need to use the equation of a straight line. Y minus y1 is equal to mx minus x1 with our point, which is 4, 6. So y minus 6 is equal to minus 2x minus 4, which is y minus 6 is minus 2x plus 8, and then just collecting the algebraic terms to one side, we're going to have 2x plus y is equal to 14. So here's a question for you to have a go at. You could pause the video, have a go, and then watch the solution. So did you pause the video? Have you had a go? Finding the perpendicular bisector of the line AB that has these coordinates. Always draw a picture is a good way to start so you can really see what you're doing. The coordinate 4, 7 is A, and then the coordinate 10, 17 is B. They don't need to be perfect, just need to be how they're orientated together. And we are after the equation of the perpendicular bisector. So we need to find the midpoint and we need to find the gradient. So the midpoint halfway between 4 and 10, sorry, we just add them up. 14 and half of that is going to be 7. If we add the y coordinates, 7 plus 17 is going to be 24, and half of that is 12. So the midpoint is 7, 12. Now the gradient of AB, if we just think horizontally, to go between 4 and 10 is 6, and to go vertically between 7 and 17 is 10. So m of AB, the gradient over the line MB, is 10 over 6, which is 5 over 3. So m of our perpendicular line is going to be minus 3/5. And then if we just do y minus 12 is equal to minus 3/5 x minus 7. Now at this stage I would times throughout by 5, so we go clear of fractions. 5y minus 60, and then take that minus 3 in, minus 3x plus 21. Collect everything to one side. Let's have 3x plus 5y and put the numbers on the other side is equal to 81. So did you get that? The next question over here, part B if you like, a line segment AB is the diameter of a circle with centre 5 minus 4. So there's our centre, and if A has coordinate 1 minus 2, 1 minus 2, so the circle goes something like this. What is the coordinate of B, which would be the other side of the circle, so that this is the diameter. So all we need to do is think, how do we get to the centre, because you'd be doing that journey again to get to the other side. So I can see I've gone down 2 and along between 1 and 5, 4. So I'm already at the centre, 5 minus 4. I need to go down another 2 and along another 4. So B will be the coordinate. Horizontally, another 4 on from 5 is 9. And vertically, another 2 down from minus 4 will be minus 6. Now let's have a look at the equation of a circle. Now you can see here we've just got one point on the circle, xy, and the radius from the centre is drawn to it. So we've gone x along here and then y up. Now if you go x along and y up, you're always going to get a right angle here, and we can see, applying Pythagoras' theorem in this orange triangle, x squared plus y squared is equal to r squared. Now you can make xy coordinates anywhere around the circle, and if we draw a line to them, then all the lengths from the centre are all going to be r in length. Now we can make right angle triangles with that r as the hypotenuse to any point on the circle, and here even though the x over here will be a minus number, if you like, we can say it's minus x and y. When you put these values into Pythagoras's formula, whenever we square anything, minus x, if it's a minus value, squared will just still be the same as the positive x squared. So it doesn't really matter that to get to coordinates all the way around the circle, you're going to be having minus numbers and positive numbers. You're going to be squaring them. Negative numbers squared are positive, positive numbers squared are positive. Any point around the circle, you're going to be able to have this right angle triangle, and they're all going to have Pythagoras's theorem applied to them. So the equation of a circle is that x squared plus y squared is equal to r squared. Now that basic formula was applied to all circles that had their centre in the origin. What if the centre is not in the origin and we've got a centre here, A, B? Now we're still having points on the circle x, y. So if you have x along here and y high, then to apply Pythagoras' theorem, we need to know what is this distance here and what is this distance here. So we can see along the x-axis horizontally, this distance here is just x minus a, and vertically the distance here is just the higher one, y, minus the lower one, y minus b. So just applying both of these and putting them into Pythagoras' theorem, we'll get the general equation of the circle that is centered anywhere you like. It's x minus a all squared plus y minus b all squared is equal to r squared. So notice that it's always minus. So if we had a circle centered at, say, 3, 2, the equation would be x minus 3 all squared plus y minus 2 all squared, and say the radius was 5, then it would be 25. If the center was minus 4, 1, then you would have x plus 4. It's always the opposite in the brackets, plus y minus 1, and say this was radius 7, then it would be 49. Okay, so now we're given 2 points that are either end of the diameter, and we're being asked to find the equation of the circle. So this is putting into practice what we've just gone through. So minus 1, 4 is one end of the diameter, and 3, 6 is the other end. So here's our diameter. So we're going to have our circle going something like this. It's not a very good circle, but we need to find what is the center. So the center is going to be the midpoint. So we can see here, if we add either of those ends up, 3 plus minus 1 is 2, and half of that is going to be 1. And then looking vertically, what's halfway between 4 and 6? Well, I can see that that's 5, but you can add either end. 4 plus 6 is 10, and half of that. So I can see that the center is at 1, 5. And then all we need to do is find what is the length of the radius. So I can go between 2 points. To go from 1 to 3 is 2, and to go from 5 to 6 is 1. So using Pythagoras, 2 squared plus 1 squared is going to be the square root of 5. So the equation of the circle is x minus 1 all squared plus y minus 5 all squared is equal to 5. Now you can leave it like that, which is in center radius form, or you can multiply these brackets out. So if we do x minus 1 plus y minus 5 is equal to 5. You're going to get x squared minus 2x plus 1 plus y squared minus 10y plus 25 is equal to 5. Then you're going to have x squared plus y squared minus 2x minus 10y, and then putting all the numbers together, you're going to have 1 plus 25 and then minus that 5 is going to give you plus 21 is equal to 0. Here's another question similar. We've actually got the diagram drawn for us. So 4, 0 is the point here at A, so 4 there, and then B is at 3, 5. There's B at 3, 5. So just having these key points on each of the axes is going to be really useful. We need to find the length of A to B. So we can see vertically it's 5. So we go 5 down there, and here it's 1. So the length, just using Pythagoras, is going to be 5 squared plus 1 squared, which is the square root of 26. And it's asking us for the exact length, and we can't find a square number that times this by something to get 26. So that is our simplified surd. Now the coordinates of the midpoint, again you can use the average of the x coordinates, but we can see that what's halfway between 3 and 4 would just be 3.5, and what's halfway up to 5 is going to be 2.5. So the midpoint is 3.5 and 2.5. The equation of C is going to be our x minus 3.5 all squared plus y minus 2.5 all squared is equal to the radius squared. Now AB, this length here, the root 26 is the diameter, so the radius squared is going to be root 26 divided by 2 all squared. So that is going to be x minus 3.5 all squared plus y minus 2.5 all squared is equal to 26 over 4. So the next question on circles is going to involve some knowledge of roots of quadratics. I'm just going to go over the 3 different types of roots that we can get before we have a look at the next circle question. So if I draw 3 different types of quadratics, one that crosses the x-axis and there would be 2 solutions or 2 roots, one that just has a repeated root and just sits on the x-axis is tangent to the quadratic, and then one that is above the x-axis and therefore doesn't have any roots. Now what if this first one sat here at x equals 1 and x equals 4? So they would be our answers, and in our brackets would be x minus 1 and x minus 4 is equal to 0 to solve to then get the 1 and the 4. Multiplying that out, you're going to get x squared minus 5x plus 4 is equal to 0. Now if I applied the quadratic formula to that, I would have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now the fact that I would get the 2 roots is determined by this under the square root, which is called the discriminant. Now if I'm going to get 2 answers, one is going to be when I do plus and one's going to be when I do minus, under that square root has to be positive in order for me to get my 2 answers. So in this case we've got a is equal to 1, b is equal to minus 5 and c is equal to 4. So let's just calculate what b squared minus 4ac is. It's going to be 25 minus 4 times 1 times 4. Times in those first, you're going to get 25 minus 16, which is 9. So when I do the square root of 9, I'm going to be doing minus b plus the square root of 9 all over 2a and minus b minus the square root of 9 all over 2a. And that's obviously going to give us my 2 answers, the 1 and the 4. So when you have a quadratic that just sits on the x-axis, say that sat at say 3, so you'd have x minus 3 all squared. where it's not just really one root, it's one repeated root. It's x minus 3, x minus 3. And so you're just going to get x equals to 3. If we multiply this out, it's going to give us x squared minus 6x plus 9. If we look at the discriminant for this, the b squared minus 4ac, it's going to be 36 minus 4 times 1 times 9. 36 minus 36 is equal to 0. So when we have under the square root here, the discriminant equal to 0, the only solution you're going to get is just this minus b over 2a, because you're not going to have two answers, because you're not going to be doing plus or minus anything, because under the square root it is 0. Now when we have a quadratic that is above the x-axis, this just means that b squared minus 4ac is going to be a negative. So when you put into the quadratic formula a negative number under the square root, you're going to get an error on your calculator, and you're going to get a non-solution. It doesn't mean that the graph doesn't exist, it just means that there's no roots, and therefore if it's a positive quadratic it must be above the x-axis. So when you have b squared minus 4ac, you have got no solutions. The graph is all above the x-axis, because when we take the square root of a negative number, under that square root, the very fact that you are taking the square root implies that the number under it must have been squared in the first place, and negative numbers squared are positive and positive numbers squared are positive. So you can't have a negative number and then take the square root of it. So here's the question that's going to need you to know for part B about the discriminant, about the b squared minus 4ac. So if you want to pause the video and have a go, or just carry on watching, first of all we've got to find the centre and the radius, and we're given the equation of the circle in this multiplied out form. So what we need to do is use the skills that we use when we're completing the square. So we're going to put all the x terms together, and then the y terms, and then have that plus 9 just on the end. Now looking at these x terms, when we complete the square, you half whatever's in front of the x term and look at that bracket all squared. So if I do x minus 3 all squared, so if you imagine them squared out next to each other and expanding, you'd get x squared. The outers and the inners would give you back the minus 6x, but then the minus 3 times the minus 3 would give you plus 9. So in order to make it equate to the x squared minus 6x, if we just take off that 9, then it's going to be equivalent to the x squared minus 6x. And then do the same with the y, so it'll be y plus 5 all squared, take away 25, and then add on the 9, and then equal to 0. The 9s will cancel, and then all we need to do to put it in centre and radius form is take that 25 to the other side. So we've got x minus 3 all squared plus y plus 5 all squared is equal to 25, and then we can just read off the centre is going to be the opposite of those brackets. So the centre is 3 minus 5, and the radius is 5. Okay, part B, we have this circle and we've got the line y equals kx. K is a constant and it's going to cut the circle at 2 points. We need to find a range of values for k. So first of all, I would draw a diagram, because essentially what we've got is the equation of a circle, which is a quadratic equation, and the equation y equals kx is a straight line, a linear equation, one linear, one quadratic. How do we solve them? We substitute the linear into the quadratic, but because we want to see what's going on, let's draw the diagram. The center of the circle is at 3 minus 5, so it's there, and it's got radius 5. So because this vertical distance down to the center is 5, I know it's going to go through the x-axis there, and if I draw a circle, is going to look something like that. Now I know it comes this side of the y-axis because you know that to the center is only 3, so I know it's over there. And we've got the line y equals kx. Now y equals mx plus c. M's the gradient, which is going to be our k. Now when there is no c, that just means that the straight line is going to go through the origin. So if I start drawing straight lines on here, you can see that straight line there, maybe y equals x, is not going to cut the circle. So we need lines that are going to just cut the circle in 2 points. So where are they going to start? And they have to go through the origin. You're going to have one that does that, and then anything that goes steeper, so goes this way, will cut in 2 points. So if I draw another one that's maybe going to go through the origin, and then it will cut in 2 places, and then this section here, the gradient of the straight line is going to be positive, but once we start getting in this quadrant here, then the gradient is going to be negative. So we'll draw some lines there. You're going to have going through the origin, and you can see it's going to have 2 points where it's going to cross. So if k is going to be negative, any line that is going to go through the origin and have a negative gradient, we can see that they're going to cut and have 2 distinct places where they cut. So range of values for k, whenever you see the word range, you're going to be thinking about using an inequality sign. So I can see straight away that k less than 0, as soon as k is negative, I'm going to have some lines that cut. But what about these ones that have positive k, and they just need to be steeper than that one that's a tangent? So what we need to do is substitute the fact that we've got the linear line y equals kx. So where we see y in the equation for the circle, we need to substitute that that is going to be k. So our equation of our circle is going to be x squared plus kx all squared, because that's what y is, minus 6x plus 10 kx plus 9 is equal to 0. Now I know we've still got 2 unknowns, but basically k is just a constant, so that can operate just like a number. We've just got a quadratic all in terms of x. So if we collect the x squared terms together, you've got x squared plus k squared x squared minus 6x plus 10kx plus 9. Now we want to set up our quadratic with something x squared, something x, and then we've still got our 9 on the end. So what is going to multiply with the x squared? It's going to be 1 plus k squared. So taking this x squared out as a common factor. What's going to be with the x's? If I have plus and then put 10k minus 6, that will be the coefficient of x, and then we've got our plus 9. Now this quadratic here, that we've got everything to one side as it were, and it's its own quadratic, so it's now representing just a quadratic rather than the circle, and we want, where does this quadratic, which would have this sort of shape, where does it just sit on the x-axis? So that is going to be when the discriminant is equal to 0. So all we need to do is take the b squared minus 4ac, equate it to 0 and solve for k, and that will give us the k where we just have the tangent, so it would be that green line with the circle. So b is 10k minus 6, so b squared is going to be 10k minus 6 all squared minus 4 times a 1 plus k squared times c, and we want that to equal to 0 for the straight line y equals kx to be tangent to the circle. So sorting this out in terms of k, we've got 100k squared, and then the outers and the inners will be minus 60k minus another 60k, which is minus 120k plus 36, and then we're going to have minus 4 times 9, which is minus 36, and then it'll be minus 36k squared, equal to 0 to find this where it's a tangent. So we've got, in terms of the k squares, just do it here, we've got 100 minus 36, so that's 64k squared. The 36's will actually cancel, and then we've just got minus 120k is equal to 0. Now taking what could come out, an 8k, and then we'll have 8k minus 15 is equal to 0. So either 8k is equal to 0 or k is equal to 15 over 8. So when k is equal to 0, we have just got the line y equals 0, so that is just going to be this line here, and then all the lines that are going to be where k is less than that are going to be in this quadrant, so the red lines, and then what we need is the lines where k is equal to 15 over 8 is going to be this green line here, and we want any lines that are steeper than that. So this is part of our answer, all the negative ones, but the other part of our answer to represent this area here of straight lines that's going to have cutting the circle twice is going to be where k is bigger than 15 over 18. Next, we've got a question where we're applying our knowledge of circles and centres. We've got two equations of circles. In part A, we're being asked to find the radius and centre for each. So the first one, we've got x plus 5 all squared minus 25 plus y minus 6 all squared minus 36 is equal to 3. Put it into centre and radius form. Taking the minus 25 and minus 36 to the other side and adding it to the 3 will give you 64. So our centre will be at minus 5, 6, the opposites of those brackets, and the radius will be 8. Now doing the same to the other one, which has just got this y term in terms of q, but the x terms completing the square there, you're going to have x minus 3 all squared minus 9 plus, and then in terms of halving this minus 2q, half of 2 is just going to be 1q, so it's y minus q all squared. You have to take away the square of the number you've just put in the bracket, so it'll be minus q squared is equal to 9. Then doing the same as we've just done, the minus 9 here on the other side will be plus 9, so that will be 18. This minus q squared on the other side will be plus q squared. So the centre will be at 3q, and the radius will be the square root of 18 plus q squared. Now we're told in the next part that the distance between the two centres is root 80, and we're asked to find two possible values of q. So let's have a picture of what is going on. Always good to have a sketch. The first circle has centre minus 5, 6, so minus 5, 6 will be here. The next one has centre 3 and then q up. So we don't know where the centre is going to be, but we know it is somewhere along that line there, so it could be there above or below, but we know the distance between the two is root 80. Now horizontally in line with here, we go all the way to here, we know that horizontally to where in line with the second centre is, this here, this distance here is going to be 8, and we've got here this distance, we can call it D. Now the centre for the second circle could be up here, or it could also be down here where we've got the distance between the two centres again is going to be root 80. So it's saying give two possible values of d. D could be in line and above or below along this line x equals 3. So applying Pythagoras, because we know this horizontal distance in the triangle is going to be 8, we can say that 8 squared plus d squared is going to give us 80. So d squared will have to be 80 minus 64, which is 16. So d is going to be plus or minus 4. Now, how high up are we? Because this is the coordinate minus 5, 6. Then this is the point here, 3, 6. And we know we've got to go 4 above or 4 below in order to make the distance between the centres root 80. So Q is going to have to be those points where we've got the centre either 4 points above 3, 6 or 4 points below. So Q will have to be 10, 6 plus 4, or Q will have to be 6 minus 4, 2. Here's another exam question, so you could pause the video and have a go, or just keep watching and we'll work through it. So we're given the equation of the circle in the multiplied out form. So for part A and B, just finding the centre and the radius. So completing the square, x minus 10 all squared minus 100 plus y minus 8 all squared minus 64 plus 139 is equal to 0. X minus 10 all squared plus y minus 8. Collecting those numbers together and taking them all to the other side should get it's equal to 25. So the centre is going to be at 10, 8, and the radius is the square root of 25, which is equal to 5. So we've done A and B. Part C. The line L with equation x equals 13, so this is x equals 13, crosses at P and Q, find the y coordinates at P and Q. So just put in the x equals 13 into the equation of the circle. You can put it in here or you can put it in here. I think I'll go for this radius and centre equation. So if x here is 13, 13 minus 10, which will be 3, and 3 squared is 9, plus, and squaring this out, you're going to have y squared minus 16y plus 64 is equal to 25. Now we've got a quadratic all in y, so all to one side, you're going to have y squared minus 16y, the 9 and the 64, and bring the 25 over, you're going to get plus 48 is equal to 0. Factorising this, two numbers that times together to give you minus 48, plus 48, sorry, and minuses are going to be involved, so signs are the same, minus and minus, and I think it's going to be 12 and 4. So y is 12 or y is 4. So the y coordinate of P is 12 and of Q is 4. Part D. Given to 3 decimal places, the angle PTQ is 1.855. So that angle there is 1.855. Find the perimeter of the sector. So the perimeter is the radius, then the arc length plus another radius. So the radius is 5, so it's going to be 2r plus r theta is equal to the perimeter. The arc length, when we're in radians, is just r theta. So 2r is going to be 10 plus 5 times the angle 1.855. And that on our calculator is 19.275. So you could say that's 19.323 significant figures. So here's another exam question. You can either pause the video and have a go at it yourself, or just continue to watch. We'll now go through it. So finding the coordinates of n, when it says write down, you should just be able to lift it off, and it is in radius and center form. So the coordinates of n are just going to be 2 minus 1, and the radius is going to be the square root of 169 over 4. Did you recognize 169 as being 13 squared? So this is just 13 over 2, which is 6.5. Now for part C, we're told the chord AB is below the x-axis and has length 12, and we're trying to find the coordinates of A and B. So we found that the radius is 6.5, and we know if I draw that radius that goes down and cuts there perpendicularly, that's going to cut the chord in half. So half of 12 is going to be 6. So if I find the length here in this triangle, just doing the 6.5 and the 6, using some Pythagoras, 6.5 squared and take away 36 and take the square root, this length here comes out to be 2.5. Now I know that the center n is 2 minus 1. So in order to get to A, if from the center, if I just go down 2.5 and then across 6 to get to A and across 6 to get to B. So A is going to be the coordinate going from 2 back 6. That's going to be minus 4, and I'm already at minus 1.5 down. I need to go down another 2.5, so that's going to be minus 3.5, and B is going to be at, from 2 going 6 this way is going to be 8, and that's also minus 3.5 down. Now part D, show that the angle ANB is 134. So I get rid of these. We need to show that this angle here is our 134. Now using the symmetry of the shape again, if I go down all the way to here and just work in this right angle triangle here and find what this angle is, and then just double it up from the symmetry of the shape, just working again in this right angle triangle, we know that this is 6.5 and this is 6. So we find that angle there by doing inverse sine of opposite over hypotenuse, and then times it by 2 will be the angle ANB. So inverse sine of 6 over 6.5 comes out to be 67.38 times by 2 is 134.76, which is 134.8 degrees. Now in part E, find the length of A to P. So A to P, this length here. So using the fact that when we have a radius meeting a tangent, they join there at 90 degrees, and similarly here. So in this kite shape going all the way down to P, we've got angles in a quadrilateral add up to 360. We've used 2 lots of 90s, so that's half of the 360. This angle here we've just shown is our 134.8, so this angle here must complement with the one at the center here to make the other 180 for the 360 in the quadrilateral. So that angle there at the bottom is going to be 45.24. Now again, if we just work in right angle triangles, so I'm going to work in this triangle here, which if I draw it out here, we know that this is 6. We're trying to find A to P. We know that this angle down here is half of the 45.24, so 22.62. So all we need to do is do inverse sine, using the sine ratio to try and find the hypotenuse, which is going to be opposite divided by the sine of 22.62. We do that on our calculator, we get 15.599. So A to P is 15.6. Here's a question where we're given 3 points on the circumference and we're asked to find the equation of the circle. So you've got to use the fact that the perpendicular bisectors of the chords joining the points meet at the center. So the perpendicular bisector of that one and the perpendicular bisector of that one are going to meet there in the center. So first of all, we need to find the equations of these two perpendicular bisectors and then equate them and see where they meet. So to find the midpoint here, to go from 0,2 to 818, I can see that to go in the x direction from 0 to 8, this coordinate here is going to be 4 in the x direction. To go from 2 to 18, that is a distance of 16, and half of that is 8. So if I just add 8 on to the 2, that will take me to 10. Or you can do the average of the x's, the average of the y's. 2 plus 18 is 20, and half of that is 10. So I know it goes through 410. It's going to have the negative reciprocal gradient of the chord. So going between these 2 points here, we can see that from 0,2 to 818, it's going to be 8 along and 16 up. So the m of the chord between A and C is going to be 16 over 8, which is 2. So the gradient of our perpendicular bisector here is going to be -1/2. So now trying to find the equation of that perpendicular bisector, we can use y minus y1 is equal to m into x minus x1. Using our point 410, we've got y minus 10. The gradient is -1/2 x minus 4. Multiplying by 2, 2y minus 20. Take that -1 in is minus x plus 4. So 2y is equal to minus x plus 24. Let's just get it in y equals mx plus c form. Y is equal to -1/2x plus 12. Okay, let's get the equation of the other perpendicular bisector, which is going to be a little bit easier, I think, between 0, 2 and 2, 0. The midpoint there is going to be 1, 1, and I can see to go through, that's going to have gradient 1. This is the line y equals x. So all I need to do is equate the two perpendicular bisectors. So x is going to equal -1/2 x plus 12. Take this over, 3 over 2x is equal to 12. So x will have to be multiplying by 2, 24 divided by 3, which is 8. Now I can see that where the two meet has got to be on the line y equals x. So, we can see that the y coordinate also has to be 8. Now all we need to do is work out what the radius is going to be. So going from one of the points on the circumference to go to this point, which is going to be here, the center, 8, 8. From 0 to, I can see that's 8 along, and from 2 to 8, that's going to be 6 up. So the radius is just using Pythagoras on that triangle that's going to be 8 and 6. It's going to be the square root of 100. So we've got 8 squared plus 6 squared, which is going to be 64 plus 36, which is square root of 100. So the radius is equal to 10. But it's asking us to determine the equation of the circle. So it's going to be x minus 8 all squared plus y minus 8 all squared is equal to r squared, which is 100. Thank you so much for watching. If you're still with me at this point at the end, you have revised and gone through everything about circles and the coordinate geometry involving circles. So well done. Please do like and subscribe. Hope you found the video useful, and keep an eye out for any more videos we're posting on the channel. See you on the next one.